Hello. In this video, we're going to study an interesting concept. And to start it off, let's look at these two angles, 598 degrees and 238 degrees. Are they the same angle? Well, we could go ahead and sketch them. 238 would be, well, this is 270. This is 180, so kind of halfway between the two of them. Maybe about here. So that would be 238 degrees. And what about 596? Well, if we took 596 and subtracted 360 from it, we would get, oh, lo and behold, 238. Which means that it's going to be at the same place, but we have to go around one time before we land at the terminal arm. So both of these angles are kind of the same. I mean, they look the same on the picture in the sense of they're landing in the same location. But I mean, they're not the same because one of them has a spiral and one of them just goes straight out. So how can we talk about these two angles? I mean, they end in the same place, so they have the same terminal arm. They terminate at the same location. The word we would use here is coterminal. These two angles are coterminal because they end or terminate at the same place. Again, they're not the exact same angle, but there is a relationship or a similarity between the two of them. So which of the following angles here do you think are coterminal? I'd encourage you to pause the video and give it a try. All right, so let's take a look at the 1,470. If we subtract a 360 from it, we'll see if it lines up with the 30. That's not enough. Let's subtract another 360. Still not enough. Let's subtract another 360. Still not enough. One more time. Let's subtract a total of 4 360s, and that's going to give us 30. In other words, the angle 1,470 is the same as going around 4 times and then landing at the 30. So indeed, these two angles are coterminal. They terminate or end at the same location. Okay, well, let's try the next one. We'll keep subtracting 360s from here until we get down to an angle we recognize. So subtract 1 360, subtract 2 360s, subtract 3 360s, and that's going to give us 50. Well, if you notice, 50 is not the same as 30, so they are not coterminal. Now, what about negative 30? You might say, oh, well, 30, negative 30, those are kind of the same. But if we were to draw 30, it would be right here. If we were to draw negative 30, that would be back over here, be going in the other direction. And so while they both might be 30 degrees away from the x-axis, one is going one direction, one's going the other direction. So these are definitely not coterminal. And if you wanted to think about it in terms of positive angles, we would probably have to add 360 to make this more recognizable. So negative 30 plus 360 will be positive 330 degrees. So technically, negative 30 and 330 would be coterminal. But 330 is definitely not the same as 30. These are not coterminal. Now again, we have to use that same idea over here. If we have a negative angle, we have to add groups of 360. We don't subtract, this time we add. So we add 1 360, another 360, another 360. We just have to keep going until we get ourselves, oh look, 30 degrees. So it turns out that this angle is also coterminal. It might have gone in the other direction, but it lands or terminates at the same location. Now let's go ahead and do this again, but in radians. Which of the following angles are coterminal? And please do your calculations in radians. You're not allowed to convert to degrees. You have to stay in the world of radians for these questions. So pause the video and give it a try. All right, so pi over 4 and 3 pi over 4, those are both good to go. They're already kind of as simple as you can make them. They're principal angles. They're between, theta is between 0 and 2 pi, or 0 and 360 if you're thinking degrees. But again, we're not allowed to think degrees. So thinking in radians, we want our angles between 0 and 2 pi. Now, 2 pi is like weird compared to pi over 4. So what I'm actually going to do is I'm going to write this as 8 pi over 4 because everything's over 4. So let's think in terms of over 4. The biggest number we would want is 8 pi over 4. So these are both good. But clearly the negative is not good to go. And the 43, I mean, that's way too big. So let's go ahead and start working on these guys. We want to add 2 pi. But again, that's really nasty with the fractions. Let's just add 8 pi over 4, so we're ready to go. Now negative 5 plus 8 will be 3 pi over 4. And so check that out. These two are coterminal. Is there another one that's coterminal? Well, let's try the next one. We'd want to subtract 8 pi over 4. But 43 minus 8 is going to give us, oh, that's only 35. We're going to need to subtract another 8 pi over 4 and another 8 pi over 4. We're going to need to subtract a number of them because we have to go 43 minus 8 minus 8 minus 8 until we get down to a number we recognize. And the number we recognize should be 3 pi over 4. That's between 0 and 8 pi. And what do you know? This is also coterminal. Sweet. Well, maybe the next one is too. So again, we subtract the 8 pi over 4. Keep doing that until you get a number that you recognize. And if you go too far by getting a negative number, just back up one step. So this should be 4 pi over 4, which is just pi. But that is not coterminal, unfortunately. It's a little bit too big. All right, let's try that 109. We want to minus 8 pi over 4 a bunch of times. In other words, we can do 109 minus 8 and just keep subtracting 8. Working on our fraction skills, we should get down to 5 pi over 4. So again, unfortunately, this one is not coterminal. So let's go ahead and take some notes on this. We learned the skill of coterminal angles. And the idea with a coterminal angle is they both terminate at the same location. So our nice example would be 30 degrees and let's say 390 degrees. They both have the same principal angle. They're both at 30. It's just that the 360 has gone around once. Or we could do them in radians, pi over 6 and pi over 6 plus 2 pi, which if we were to write that as a nice fraction would be 13 pi over 6. So as an example, I'm going to give you 3 angles. I'm going to give you 45 degrees, 11 pi over 4, and 42 pi over 8. Your goal is to see if any of these angles are coterminal. So go ahead and pause the video and give it a try. All right, assuming you gave it a try, I think we're going to convert this into radians because 2 of them are already in rad. So let's just take this one. This will be pi over 4. And we can simplify this one as 21 pi over 4. This one is already 11 pi over 4. All right, well, the pi over 4 is in the range 0 to 2 pi. But the 11 pi over 4, we got to fix that one up. So we're going to take the 11 pi over 4. We're going to subtract 2 pi. Which means we got to work on our fraction skills. 11 pi over 4 minus 8 pi over 4. So it'll be 3 pi over 4. All right, so pi over 4, 3 pi over 4, those two aren't coterminal. But maybe that last one is. So let's go ahead and grab the 21 pi over 4. And we got to subtract a 2 pi. Although that'll be 21 minus 8, which I actually don't think will get us all the way. We probably subtract 2 pi twice. So that's 21 pi over 4 minus 8 pi over 4 minus another 8 pi over 4. So 21 minus 8 is going to give us 5 pi over 4. Oh no, well that's different from both of them. So the answer here is that no coterminal angles. Bit of a tricky question there. None of these 3 angles are coterminal. All right, so for some extra practice, you can grab an example from worksheet 3 or 3.5. And then any things to remember, I would definitely encourage you to work on this idea with the pi over 3, let's say, plus 2 pi. We got to work on our fraction skills, so you can put this over 1, multiply by 3, multiply by 3. That's going to give us pi over 3 plus 6 pi over 3, which gives us 7 pi over 3. So when adding or subtracting the 2 pi, we do it just like fractions, and we think here, if you have 1 pi and you have 6 pi's, that makes 7 pi's. So once you do a couple of them, you should get the hang of it. But you do need to be comfortable with your fraction skills here for finding the coterminal angles, especially when working in radians. All right, hopefully you enjoyed this video, and as always, thanks for watching.